Welcome and hello. This is a video lesson using the HEC-RAS controller called Finding the Node ID, River Station, and Node Type. So what we're going to do is use the HEC-RAS controller, some of the functions specifically in the geometry subclass, provide it the river ID and reach ID, and then obtain the node ID, river station, and node type for all the nodes. So what I have on the screen right now is my HEC-RAS. Down here you can see the geometry. This is a 1D model. I've got a single river. It is a single reach with a number of cross sections, and you may notice I also have a lateral structure connected to a storage area as well as a bridge. So the lateral structure is at river station 780, centered on river station 700. The bridge is further downstream at about river station 190, 180 or so. This lesson is rather fundamental, meaning it's rather elementary, but also important stepping stone for using other features and procedures within the HEC-RAS controller. The end result of this lesson is what we're seeing down here in the intermediate window. This table right here is the end of the lesson. So what we're going to be doing is extracting the node ID in this 1 through 13, the river station number from 1,000 down to 0, and then the node type. Most of these node types you may notice are XS for cross section, but there's also a node type for lateral structure and bridge representing the lateral structure and the bridge based on the provided river and reach. There's no storage area in this table. The storage area is not technically a node on the reach, but it is connected through the lateral structure, and that lateral structure is a node on this reach. So that's the direction we're going with this lesson. This node ID and the river station could be really important and a required parameter for a number of the other procedures in the HEC-RAS controller. All right, so commit this particular geometry to mind. We're going to take a closer look at the code here, and I'm going to close the intermediate window and scroll to the top. The subroutine we're going to run is this one here. I'm just calling it print reach data. That's something I named. And we're going to pass this get RS data subroutine, the river ID and the reach ID. Now, since I only have one river and one reach, it was a pretty safe bet to assume that those numbers are 1. But if you happen to have a network that is much more complex with multiple rivers, each having multiple IDs, then there are also functions in the HEC-RAS controller to extract the specific river ID and reach ID that you're most interested in. All right, so assuming that we know the river ID and the reach ID, we're going to pass those values into this get RS data. So if I scroll down here, this is the main function we're going to talk about in this lesson. Get RS data, it's going to print the node ID, river station, and node type for each node on a given river and reach. That was that table we saw at the very beginning, which is our results, which we'll also revisit at the end of this video. All right, so we're passing the river ID and the reach ID. We are creating a HEC-RAS controller object on this line right here, and then we are assigning it to our specific HEC-RAS project file, the .prj file. The first function we're going to use from the HEC-RAS controller is inside the geometry subclass, and it's node. We're going to pass it the river ID and the reach, and it's going to return long, which is going to be the total number of nodes on that river reach. So 1 and 1 are the two long data types we're going to be passing in for river ID and reach ID, and it's going to return our number. So our number happens to be 13, but it could be 5, 10, 50, 100, however many nodes are on that reach. We're going to be using this node count long as the maximum value for our node ID. So the very first node is going to have a node ID of 1. Typically, I've noticed it's upstream to downstream, which means this very first node ID 1 will be the upstream most structure, most likely a cross section. And then node count 13, or whatever the total count of nodes is, will be the last value for node ID. Now this node ID here is what we're printing out in the table. I got the F here, so I'm just formatting it so it's 2 characters, but that was just so it looks clean. It's really just the same value, but converted to a string and adding an extra space if necessary. All right, so given a node ID of 1 or 2 or 3 or whatever, we're going to use this node RS function. We're going to pass it the river ID, the reach ID, and then the node ID. So we're going to have a 1, 1, a 1, 1, 1, 1, and 2. The only thing incrementing here is going to be the node ID from 1 up to 13. And it's going to be returning a string, and that is the river station, which could be either 1000 or 900.00 asterisk or 800.00 asterisk, as you will see for cross sections that are interpolated. Or if it happens to be like my lateral structure, I believe is at 780, or my bridge happens to be at 190. And again, I'm putting the double quotes in here because it's returning a string. See, RS is defined as a string variable. The next line down, I'm getting the node type ID. This is a long integer, and we're passing it the river ID, the reach ID, and the node ID. We're using the HEC-RAS controller, specifically the geometry subclass, and this node type is the name of the function. I kind of wish it would say node type ID, but it's returning a number, so that's why I'm calling this variable node type ID. That value is going to range between 1 and 6, so 1, 2, 3, 4, 5, or 6. 1 represents a cross section. 2 represents a bridge, I think. Well, I don't need to guess because I wrote the next line down is to actually get the node type, like the name, the string of the node. So this node type function is right down here. Okay, I'm stand corrected. 2 is covert. This function receives a parameter, which is node type ID, 1, 2, 3, 4, 5, or 6. And then we use this select case structure to return the name of that node type, either a cross section, a culvert, bridge, multiple openings, inline structure, or lateral structure. So for our bridge, it would be passed in a 3. That's the node type ID, the node type name. I guess I could have called this node type name just the same. And then node type ID 6 will return a node type name of lateral structure. So that's pretty much it. This last line here will print the results for our node ID, the river station as a string, and then the node type also as a string, the descriptor, cross section, bridge, lateral structure, and we're going to see that printed out in the intermediate window. So I'm going to go to View and then Intermediate Window. Here is the results. I'll go ahead and delete that so you can actually see it run for yourselves. Just move this out of the way, scroll up to the very top where we have our print reach data, and then click on the play button to run the subroutine. And then here again are our results. So in the future, if you needed to perform the same action on a specific river and reach, you now have a function to give you all the data you need to identify the node ID, the river station as a string, and the node